Hello and welcome to IoT Made Easy with Node-RED and InfluxDB. Today's webinar is sponsored by Influx Data and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might have. Browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we will provide further technical assistance. In the handout section of your webinar control panel, you'll find that we're offering several resources, and I'd especially like to call your attention to links to get started with InfluxDB for free and InfluxDB IoT use cases, as well as a PDF on why time series matters. Also in there, you'll find a link to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Event Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Now, at the end of this webinar, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. Now, with all that out of the way, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today. We have Charles Mahler, who's a technical writer with InfluxDB. Charles, welcome.
Thanks for having me.
Great to have you here. Yeah, take it away.
Cool. So, kind of as you got during the introduction, we're going to be going over IoT, how you can use Node-RED to kind of do stuff with those use cases and how InfluxDB fits into that. So our agenda is to start off just for those not familiar with Node-RED, I'll cover kind of what it is, the history of it, the fundamentals, basics of getting started with it, what you can do with it, kind of the core components, then go over how you can use a time series database like InfluxDB with Node-RED and the benefits of that. And then we'll go into some examples, so from basic to intermediate to advanced, Node-RED workflows, and then finally we'll end up with some companies in the real world, how they're actually using Node-RED as part of their product. Big thing to keep in mind here is the focus is really on kind of the how and the why, kind of give you some inspiration for how you can use this maybe in your own work or just for fun on the side, because there's a lot of, it's a pretty powerful tool, so you can't really cover everything in detail. So the main goal here is to kind of just make you aware of the different types of things you can do with it. So what is Node-RED? So essentially it's a low code or no code programming tool. It was developed by IBM and kind of initially focused on IoT type stuff. They open sourced it in 2013 and it was picked up by the JavaScript Foundation in 2016. A lot of the times I see Node-RED can kind of get seen, it's used a lot for home automation type stuff, so it gets kind of written off as like, oh, it's just kind of a toy project, use it for hobbyist type stuff. But there is really big companies like Samsung, Bosch, and others that are using this as part of like their services. So there's big time companies that are using Node-RED in production. The other thing, and the bottom left of this is just a star chart on GitHub. So like obviously stars aren't everything, but the key thing is you can see that over time it just continues to grow. So if you take the time to learn a new tool or any open source project, you want to make sure that it's not going to get like abandoned or that something like that, like it's worth your time. So you can see that the project just continues to grow. And really, it's, if anything, accelerating over time, because as it builds up, as the community contributes more to it, it just gets more valuable. And there's a roadmap out to 2024 already. So just this last July, they released Node-RED 3.0, and in next April, they're going to be releasing 4.0. So they've added lots of stuff that really make it more usable. There's a lot of things for like workflow related stuff, kind of UI elements that make it more user friendly compared to like in the past. So it's a lot of stuff that now they're like in the fine tuning stages to make it much more accessible even to like non-technical people in many cases. So kind of the key, like at the start, is that they wanted to make a tool that made it easy to combine hardware and software, easy to kind of integrate them for IoT type things, in a lot of cases like industrial type workflows. So that has changed over time, and now you'll see a lot of situations where it's actually like software to software, where you just want an easy way to integrate different APIs, connect them together, and not have to kind of mess around with like the low value stuff. It's like no one wants to just spend a lot of time like writing code that just glues stuff together. And that's really the selling point of Node-RED, is that because the community is so big, pretty much any tool you use on a regular basis, there's probably already a node to input and output data, to communicate between those. So it's that's kind of where it's moving towards in some ways, is that it went from pure IoT and now it's good for pretty much any kind of use case you'd have as a software developer or just somebody who wants to connect different kind of data pipelines together. So some common use cases, these are from a Node-RED like community survey. So there is a lot of home automation type things. So you can connect, if you have a security camera, if you have just a smart like thermometer, pretty much like lighting, anything like that, you can connect all those different tools together using Node-RED, and then you can automate stuff. You can optimize, make your house more efficient, control the temperature, the lighting programmatically, all sorts of different things for home automation. You also have data visualization. There's tools built into it to create dashboards that you can host online. Like you can create either an API endpoint, or it can also just output HTML. So if you want to create data visualizations of data you're collecting, it has that built in. You can obviously also just pipe that data to like whatever kind of charting tool that you use. It can also be used for creating REST API endpoints or webhooks. So if you have like an event-driven type architecture, you can create like a webhook or an endpoint that listens and is basically just there waiting to respond to whatever requests get sent to it. You can then combine a bunch of different flows and kind of process that data and then send the output back to wherever you needed to send it. And then data processing and edge computing, those can kind of, in some cases, be part of the same thing. So you can do like, obviously there's pre-built nodes, but you can write your own JavaScript functions as well. So if you need something custom that there isn't already kind of something there for, you can create custom functions to transform and manipulate data. And depending on like the volume of data, you might in some cases want to offload to a different service. You don't want to, like, Node-RED is at its best when it's kind of acting as the glue between different systems, between different tools. So you don't want to do too much heavy lifting, I would say, just because it's kind of not what it's intended for. But you can do like kind of standardized data before you output it to its destination. And because it's open source, you can deploy it on the edge. It actually has the ability to, like if you're in a resource constrained environment, you can separate the actual runtime from the user interface. So you can drop the user interface if you don't need it, if you're deploying it to like some sort of embedded device and you just want to be able to run the code itself, and you don't want that overhead of the UI. That's another thing you can do. So it's very flexible in kind of how you can deploy it. So the main benefits, I would say, are just the productivity. Like developer time is very valuable. And in a lot of cases, because of these nodes, you can have non-technical people kind of build out their own thing. Or in the rare case where there's not, like the developer can jump in, create the custom node, and then other people can utilize those. So you don't have to kind of reinvent the wheel every step of the way. You also have access because it's JavaScript. So you have everything in the NPM ecosystem. You can import packages and use those for your custom functions. So if there's not like a dedicated node already built, you can always just import from NPM, wire everything up, and do it that way. And there's actually, and one of the use cases we'll cover later, a customer says that like they've shown that compared to like doing it essentially having to rely purely on developers, if you use Node-RED, they showed that like deploying the same features for creating like certain tools and stuff that business use cases wanted, they were 12 times faster when they used Node-RED. So it's pretty significant improvement in productivity. You also have the portability aspect. So kind of touched on that earlier with the runtime. If you don't need the UI, you can interact with it in different ways. You can import and export flows. So like if you made some entire workflow that you think can be used by other people, you can export that as JSON and then they can import it. You also have kind of like their community hub where you can upload different things and people in the community can search through that hub and then pull what they want from it. And then finally, the community, again, a big benefit of open source is that probably when it's like this big of a project, if you have something that you want to do, there's probably somebody that's also already kind of ran into the same problem and made something that will solve that problem. So again, you don't have to reinvent the wheel a bunch. A quick Google search, a quick search on their website, you'll probably find something that gets the job done. And also, because there's so many businesses now that are relying on it as like a core part of the product, there's always constant improvements in terms of performance and just more features being added into the core product itself. And I'd say kind of putting all those together is like the biggest benefit or kind of the biggest selling point for me is that it really just gives you a ton of flexibility in how you handle things. So for an example, like you could do, like if you say you have like a sensor or a device that you're collecting data from, you could process that data on the device before you send it to Node-RED. You could also send it to Node-RED, then process it, transform it, or you could use Node-RED, pass it off to like a stream processing tool, then put it back into Node-RED, and then send it to its destination. So depending on kind of your architecture, your environment, like your network connectivity, all those things, Node-RED is so flexible that you can basically kind of modify how things work and it'll work for your situation. So now into kind of how you get started, we're going to look at the editor first. So basically, there's three main components to your editor. So on the left is where you have essentially your palette of like the different built-in nodes. So I forget the exact number by default, but you have different ways that you can essentially inject, like there's stuff to kick off a workflow, you can schedule them, you can do different like filters. So there's different types of nodes there, and that's going to have your list. And if you download community nodes, they will also show up in there. So that's basically your kind of toolkit, shows you everything you have available there. The middle of your workspace is the actual kind of editor, and it's where you can organize your nodes, kind of see everything that's going on. So a big thing, you can have multiple tabs. So you can have kind of like normal programming where you don't want one giant workflow, like one giant like spaghetti code equivalent. So you can have multiple tabs with different workflows together, and you can either chain those workflows, you can have different what are called subflows, and basically they give you a lot of different ways to kind of organize things so it's easier to understand, so you don't just have a giant mess that you forget how everything all works together. Everything's drag and drop, and they've added like in version 3 a lot of like right click kind of usability, so you don't have to like command shortcuts and stuff. So like from a usability perspective, it's gotten a lot better in the past kind of few months and years. They put a big emphasis on that. On the right, you have there's 4 different kind of columns or whatever tabs that you can click through. So you have your information tab, which will show you like whatever node you have highlighted. It will show you information about it. You also can look into like debugging view, which is very useful. It shows you like at each step of the flow, you can see like what is the message body, what does it look like, what is happening to the data. If you have some sort of issue where you're not getting the output that you want, you can walk through it step by step. You can do like a console.log, that sort of thing, and see what is happening. So that helps speed up kind of your development. You can also have configuration, so you can have like global variables, API keys, stuff like that. And then finally you have context, which shows basically the state of like Node-RED at various points. So you can look at essentially the data that you have and what's going on. So the example for this one, the actual workflow itself is just an MQTT essentially function. So it's listening to, it's subscribed to an MQTT broker. It's listening for a message. The green box at the bottom is just console.logging the message. And the one above is essentially a JavaScript function that transforms the message a little bit, and then it sends it to the InfluxDB output for storage. So flows, beyond just to basically zoom in on it, flow is essentially any connection of your nodes. You're going to have an input that can be scheduled. So like every minute it inputs this value. You can have, in this case, an HTTP endpoint, and it's listening for a GET request. And what it's doing is once it receives that, it pulls off the parameter on that request, and then it sends it to an HTTP, or it sends it to an HTML template where you can kind of customize it, style it, pull in different things. And then finally it responds to the request with just a basic HTTP response. So you have your input, your output, and then anything in between that is what those other nodes are for. And then the nodes themselves, so this is kind of, if you zoom into, like, you can see what's going on with each of the nodes. So in this case, it is that template node. I think they use, handlebars. I think that's the framework they use for modifying and creating these templates. You could also use a variety of other tools just via npm. Instead of using the default template, you could just use a custom node for that. And finally, messages. So this is what every step of the way, you get an input message. So whatever triggers the flow at each step of the way, this is basically the body. So you'll have your message payload, and you'll have some additional fields on that message you can manipulate. But pretty much with the message, you can add fields, you can remove them, you can filter them, or you can access specific properties. It's essentially just a JavaScript object. So anything you could do with a normal JavaScript object, you can do with the messages as they go through your workflow. So these are kind of the types of nodes. So you have storage, outputs to different like databases, different like if you want to use like S3 for file storage, that sort of thing. There's a lot of different options there. You have utility nodes, is which I would call them, which is for like specific tasks where whether it's some sort of transformation, there's some that are built in, like modifying strings, converting the type. There's all sorts of utility nodes. You also have then control nodes. So this is kind of like pretty much anything you would do in a programming language. You have switches, you have like basically if else, you have conditional type things. So you can have, depending on the input, you can kind of change the direction of it, where you send it, what you do with it. Like you could just, like if the field name is incorrect, if there's some formatting issue, you can just stop the workflow there and return an error. And if it's fine, you can pass it on to a different either subflow or just continue it down in a different branch of your workflow and continue like the kind of the pipeline of what you're doing with that message. You have your integrations. So there's tons of different, like pretty much all the most popular, you can think about like Twilio, really any API, there's probably a pre-built integration. So you can either send the output to those services, or you can also, as part of your pipeline, grab additional information from an API. Maybe you have like, for example, like you get some input, like some sort of text, and you want to do like sentiment analysis, for example. You could either have your own pre-trained model that you hit up, or you could hit like a dedicated, like there's a lot of different providers for like machine learning model APIs. So you could do that. And finally, you have your protocols like MQTT, HTTP, pretty much any, and like there's a lot of very niche ones for like industrial IoT type things. So there's a ton of different protocol support for input and output. So these are just some nodes I think are kind of interesting. So for example, like the exec, that allows you to execute on like your local machines. Like if obviously you're using JavaScript inside Node-RED, but let's say you want to do something like for data analysis or something, and you want to use Python, you could essentially reach out to some script you have written, and Node-RED will do the input, and then it will take back the output and just treat it like a normal message once it's been processed. You can create WebSocket endpoints. You can do templates, like it kind of mentioned earlier. You can parse HTML, so you can give it a URL. It'll reach out. Like if you want to scrape some sort of URL, you can do that. And then MQTT is another very commonly used one for a lot of IoT workloads. Community nodes, we have Twilio. If you want to send a text message to yourself, notify yourself, like for home automation, maybe some number is out of range, you set a threshold, and then you want to be notified if something's wrong there. It'll send you a text. You have chatbot integrations, so again, kind of another way to take input and then notify, or you can also automatically, you can do the reverse where you can listen to or listen for messages via kind of those APIs. You can send and receive emails. You have, and then database connections like MySQL, InfluxDB, and there's also a very tight integration with Home Assistant, which is a kind of home automation platform. So benefits of using a time series database with Node-RED. So community survey, just to like InfluxDB is actually the second most popular database to be used with Node-RED according to like their own community. The most popular is MySQL. I think it's like 24% say they use InfluxDB. I think it's like 32% for MySQL. And I think an aspect of that is that for a lot of the situations where you're using Node-RED, it makes sense to go with a dedicated kind of time series database. Lots of like metrics, lots of sensor data, and the kind of performance reasons that InfluxDB and other time series databases shine here is one, like the ingest rate. So if you have tons of different sensors, InfluxDB can handle a lot of write throughput. So as it gets funneled through Node-RED to your database, like a lot of relational databases will struggle with that depending on your workload. Again, once you have your data written, it's kind of useless if you can't efficiently query that. So time series databases are optimized for querying within time ranges like you would get with a sensor data or metric data. And finally, another big thing is the compression on your data. So with InfluxDB, you can essentially store way more data for the same or less price because it's optimized. It's able to essentially get a better compression ratio on this data. So you can store with higher granularity and it's not going to like break the bank. Okay, there we go. The other big thing is developer experience. So with InfluxDB, the query language is designed for working with time series data and these types of things. It saves you a lot of time just because like we tried to with like SQL, a lot of cases it can take, you're kind of, like there's not a lot of built-in functions for doing a lot of these things like getting a moving average, downsampling data, querying based on time range can kind of be messy. So you save time just in writing your queries. InfluxDB also has a new feature, a relatively new feature called edge data replication. So that allows you to move your data from, if you have the InfluxDB open source deployed like on the edge right with your Node-RED deployment, you can then automatically offload that data if you want to like duplicate it to the cloud or to another instance of InfluxDB. You can do that. You can downsample it and then send it to the cloud for like long-term historical analysis, which we have a few kind of customers doing in production now. And then finally, there's an ecosystem of tools around InfluxDB, like Telegraph, which allows you to kind of similar in a way to Node-RED, which is it's an input and output tool and can kind of transform and modify data before being stored. And this is just a chart from DB Engines, which kind of shows that a lot of other developers are essentially seeing the value of this. That chart shows that I just saw some pop up in the chat. Anyway, so you see like the kind of the strengths of time series are a good fit for a lot of what you're doing here with InfluxDB and Node-RED. So these other databases are kind of more general purpose and not really optimized for this. So depending on the volume, it might not be a big deal. Like there are people where if it's just like for a home automation use case, you could probably get away with using a relational database or whatever. But if you're scaling to a kind of at a certain point, it becomes more cost efficient and just more kind of rational to use a kind of specialized solution. And again, that chart's from a DB engine, so it basically tracks over the last 2 years by adoption rate, and the highlighted blue line shows time series databases compared to some other ones like graph databases, document databases, all those. So onto the example workflows. So this is pretty much the most basic example you could have, which is basically it's just an inject node, so you can put in whatever you want. You manually trigger it, and this is it's a good node just for basic testing when you want to be able to kind of control different types of data that eventually will be getting sent through this workflow. So all this does, it takes the input, hello world, and then it outputs, it just does a console.log. So that's about as simple as you can get. You have an input, and in this case, you don't even have an output. So intermediate, what this is it's a web scraper. So the input node here is that it's scheduled to run every 5 minutes. You then give it a URL where it makes the request. It uses that parser to grab, so you can use CSS IDs or different, pretty much any way you'd want to grab an HTML element. You can get that specific value. It then checks the value, so it's just a conditional, like if value equals this, it'll then pass it forward, and that's what that switch element does. If it isn't a true, like if that conditional isn't true, it just stops there. And if it is true, it'll then send a post request to, it could be like whatever webhook you have to notify yourself, or that post request could be replaced with like a Twilio API integration, and you could text yourself. I think I designed this back when like Raspberry Pis and everything weren't in stock, so you could basically send it to Amazon or a different website, check if whatever you're looking for is in stock. If it is, send yourself a text message, and then quickly go order whatever you're interested in. So this is a really advanced use case where there's a lot going on, but essentially it's for controlling a vehicle using Raspberry Pi. So I pulled this from the community. The input here is a Xbox controller. So it takes that input from the controller, it essentially transforms it into something that is recognizable, and then it outputs the commands, like whatever you're doing with the controller, whatever button you clicked, it outputs that to an MQTT broker, and it also sends it to a dashboard. So it uses the Node-RED dashboard UI, which will create like different kind of charts, different gauges based on that data. So that's just for kind of visualizing what's going on as well. And then on the other end, we have, this is how it's essentially received. So you have these nodes are then subscribing to the same MQTT broker and waiting for that data to get passed through. And then once it receives that data, it then sends the controls to the vehicle. So on to the real world use cases. So this is Prescient Devices, which is an InfluxDB customer, and they were the business I mentioned earlier where they are for deploying and managing edge computing. So they have their cloud-hosted Node-RED instance with the UI, and then customers build their stuff there, they build their workflows, and then it allows them to kind of seamlessly deploy it to their edge devices. So it says they're able to get 12 times, like in whatever surveys, I don't know if that's across all their customers or just a specific use case, but they're able to essentially build the same feature and see a 12 times boost in how fast it was to release that feature. So this is their architecture. So they use in the cloud, they have InfluxDB for like storing historical data. They also use like Grafana, TensorFlow for building models, Grafana for visualizing various data points. They push that then to the edge, and they also use InfluxDB open source there. And Node-RED without the UI can then call on those TensorFlow models, whether it's like could be image recognition on a security camera. It could be analyzing like a anomaly detection, like if it's some sort of temperature reading. It can take that data, Node-RED funnels it to these machine learning models, and then they can essentially pass anything back, anything they want to send back to the cloud, like historical data, maybe less like downsampled, less granular data. They can then send that back from the edge to the cloud for long-term storage. We have AdLink. So this is they specialize really in helping various kind of industrial IoT and different companies implement edge computing. So that's kind of their specialty. For this specific use case, they use Node-RED and also InfluxDB within aerospace companies. And what they wanted to do was reduce the number of outages they have, because in this case, like they had a specific machine that would break down. They couldn't really predict it. And every time that went down, they had to call in, fly in a specialist to repair it. And I think they said like every outage cost roughly $100,000 just because it would shut down the entire like assembly process. So what they want to do is essentially predictive maintenance. So at the very least, they could ahead of time predict when this machine was going to break down so they could just have the repair guy ready. So this is their architecture. They use InfluxDB on the edge to collect with finer granularity data from these machines. And what they're able to do, in addition with Node-RED, which is used kind of again as glue between all these different systems, is they're able to find basic correlations between like when the temperature reading and different other like maybe pressure, these different sensors that before they weren't collecting at a high enough frequency to really find any connections between them. And what they're able to do, thanks to InfluxDB being able to handle a lot higher scale, they were able to find, okay, when this happens, you can estimate like maybe in a couple days this machine's going to break down. So they could then, instead of just being reactive, they could be proactive. They could call the repair guy and then just kind of shut down the line on their timeline and then just fix the machine before it actually broke down completely. Graphite Energy is another customer of ours. So what they do is pretty cool. And the problem kind of with renewable energy is that, especially like solar and wind, is that you can't, like the sun obviously isn't shining at night and the wind isn't consistent. So the problem for like industrial manufacturing companies is they need a steady supply, a steady reliable supply of electricity. So what Graphite Energy does is they essentially convert this renewable energy. They call it, they put it into what they call thermal storage, and then they can use that later to essentially generate electricity. So, and then they sell that electricity to these industrial kind of companies that are whatever they're building. They need that reliable energy. They don't want up and down production. So they use Node-RED as used at the edge for data collection and processing, and then they use InfluxDB for storing both at the edge and the cloud. So this is our architecture. The interesting thing here is that they initially start off with just a relational database, and it could only handle, I think it was approximately like 15,000 data points per day is what they're storing, or 15,000 records per device per day. That was the limit. And then also the other issue was the query performance was so bad that not a lot of people were even like doing analysis on the data just because it was so slow that they couldn't iterate very fast. So with InfluxDB, they were able to bump that up to 1 million records per device. They went from taking data every minute to every second. And what they found is kind of like an unexpected benefit is that because the queries are so much faster, that a lot of people that really weren't working with their metrics data before, just because they could, kind of like for fun, they started looking at their data and they got a lot of nice insights. So at the edge, they mainly use that data for like performance monitoring and like to make sure everything's working properly. They store very high frequency data just to make sure they can respond quickly if they notice some issue. They then offload that data to InfluxDB Cloud, and then they use that for like business type decisions. So they can look at, okay, solar in this situation is doing better than wind. Maybe we should put more money there. Or this location is doing very well. Maybe we should put more solar panels, for example, that sort of thing. So it's not only used for operational type stuff to just monitor equipment, they also use it to kind of make long-term decisions in how they invest. So Loft Orbital, they are a SaaS, but they're not software as a service. They are a satellite as a service. They're kind of an extreme example of edge computing. And what they do is they're like a ride share for companies that either don't have the money to or just don't have the expertise to like launch their own satellite. You can put whatever equipment you want on their satellite and then transfer data over their platform. So their architecture, they send it down from their satellites, they collect it, they then use InfluxDB to kind of transform, modify, and they also use Capacitor, which is another InfluxDB product that's kind of for stream processing. So they do all this different kind of manipulation to the data. They then send it to InfluxDB Cloud, where their users can actually interact with their data through the APIs they provide. And it's kind of like white label in that sense that the end user doesn't necessarily know they're using InfluxDB, but that's what is storing their data. And I will say they were another situation where they were using a relational database when they started, and they ran into issues, and that's kind of why they migrated over it. Is that they knew over time they were adding more customers, and at the time it was kind of working, but they just knew eventually they're gonna have to make the switch, and that's why they went with InfluxDB. Is that they reached that point where they're moving so much data that it just wasn't practical to stick with a relational database. Finally, we have Wayfair, which is an e-commerce company. And what they kind of do with influx data, it's another example. I think that you can almost see data centers when you have multiple. It's almost like can be treated as an IoT device because you're going to have issues with the data centers. Sometimes you might have outages between data centers, so you have to plan for that. Just like if you have a device that's collecting data, you might lose network connectivity. So you have to build in resiliency and things like that. So it's almost like can be thought of as like a giant kind of IoT situation where each data center is its own independent thing. So they use InfluxDB locally in each data center, and then they use Kafka in this situation. They use Telegraph, which is a InfluxDB kind of tool. They use that to move metrics to Kafka, and then they send that back to their main data center for like long-term storage and stuff. So they use it mainly for metrics related to their like applications, making sure their software is running properly. They also do real user monitoring and kind of load testing. So like before the holiday season, like Black Friday and Christmas are big e-commerce days. So they want to make sure that their website can hold up to all that traffic. So they preemptively kind of test whether like under this much traffic load, will our services hold up and will the performance be what we expect? So they do a lot of stress testing, and the system for storing that metrics is part of that. So that's it for me, and we can move on to questions if there are any.
Okay, super. Yeah, Charles, those are really cool examples of the way people are using InfluxDB with Node-RED. We've already got a bunch of questions from the audience for you here, and keep those questions coming, everybody. We've got plenty of time. But the first one here, they're asking, what are the weaknesses of Node-RED in your experience?
So I'd say there are a couple things. There's really no built-in way out of the box to handle like horizontal scaling. So right now you kind of have to figure out, like, obviously the easiest thing would be like just vertical scaling, like put more resources on wherever you have it deployed. I think there has been some discussion with building something like out of the box where like maybe like some sort of like load balancing, so you can replicate your Node-RED instance and it just handles like the traffic load. I think right now the only way is you kind of have to build your own load balancers. So like if you have a huge volume of traffic, you kind of have to roll your own solution to that. And the issue could be that since there's a lot of these companies now that are building platforms on Node-RED, you run into the issue where it's like they're going to keep it as part of their proprietary solution. So there's no incentive unless somebody from the community really drives that.
Gotcha. Okay, great. Rashab is asking, how scalable is Node-RED?
It's kind of similar, I think, to the last one, or that, because I kind of covered it. Like last question, I think was like the weaknesses. So how scalable is it? It's going to depend on. I think it's kind of like it's written in and like it's written in Node.js. So a lot of the weaknesses related to that are going to apply for like your workload. It could be very good for moving around data, but if you like try to do heavy processing of your data in it, it probably wouldn't be ideal. And that would be a situation where the solution would be moving it out to like a dedicated like stream processor or whatever tool. You could, instead of doing the processing in Node-RED, you send it to a different tool and then you send it back to Node-RED, and then that can do what it does best, which is just kind of forward data around between different tools.
Okay. Yeah, and you hit the second part of Rashab's question, which is he was wondering how complexity affects that scalability. Aside from Node-RED, how well does InfluxDB scale?
Again, it's one of those for depending on the types of queries you're doing, the read volume. It comes down to hardware as well. But we have tons of customers. You can't really say for hardware like write throughput, but it's usually like hundreds of thousands of writes per second as long as the hardware is set up. And depending on how you tag your data, and there's kind of different things there. I will say we do have like a new storage engine that's in beta right now, and it will be rolling out in January, which is like essentially column based. So it's much better at compression, and it can handle actually like a variety. It maintains performance on different types of data. So that's something to check out. We're still kind of benchmarking it in some cases, but as far as query performance and stuff, it really has improved significantly.
Okay, super. The next one they're asking, how does the InfluxDB Edge data replication feature work?
So basically, you given an endpoint, it's like another InfluxDB instance. So that can be either cloud or another OSS instance, and it will then like handle for network connectivity. So if connectivity is lost, it will buffer that data as it's written. And in other cases, like once it's reconnected, it can then send that data. If there's a stable connection, it'll just continuously, as it writes data to the local instance, it'll then send it also to replicate that data to the other instance. So that can be used, like I said, it can be used either locally, like it can be multiple OSS instances, or you can also go to like cloud. So that'd be a good for this Node-RED type situation. Um, that'd be a useful fit here, where you have your local like Node-RED and InfluxDB deployed on edge hardware, and then you can figure out like however you want, like whether you want to downsample your data and send it to the cloud, or just send all your data to the cloud. That's another way you can do it. And the reason we built it is kind of like um, that Wayfair example where they used Kafka. Like they had to add another piece to their architecture to kind of do that same thing to move it between data centers. So I think the idea behind building out that feature was that something that customers or users are previously having to like roll their own kind of solution. We just built that into the open source so that you don't really have to worry about that.
Okay. All right, great. Um, you know, Kathy is asking, do you have a way to sync cloud service provider time series databases? So she's got some clarification here that, when two IoT devices send data, one device may send it to a gateway different than the second device, and cause some conflicts or whatever. Any thoughts on that one?
Yeah, so it says, so data arrives in time series database, time is off in a few seconds. I know for InfluxDB, you can define a timestamp in the data you're sending. So that would probably be in that case. I think that issue would be that, like, if you don't include a timestamp with your data for InfluxDB, um, it'll just stamp it as it's uploaded. Like, it'll automatically do that. And I think that's an issue that she's kind of referencing, is that even though a data point might be older, because it doesn't have it already predefined, it would get uploaded in the database and it would seem like it's seconds later. So um, for InfluxDB, at least the solution there would be that when you send it, you predefine like on the device or whatever the gateway is, you'd predefine like the timestamp, and then that would be known by the database and it would be ordered properly once it gets stored.
Okay. Question here from Marco is wondering about what are the advantages of time series versus event data?
Yeah, in some cases they can be kind of the same, and that's like the angle. Like I mentioned, our new storage engine was that um, that was one of the big reasons for this move and how the data is stored behind the scenes, is we wanted to be able to support like event data rather than like a metric. So I think there is almost like you can see like everything is time series. Like that's something like some of our founders have said, like everything in a way can be seen as time series data. Like anything like even an application like this write to the database that we updated the database at this time, like the value before was this, at this time got updated to this. Like there's kind of goes into that kind of like there's event driven architectures, and I forget the exact name for it, but there's like event stores where that's how they actually handle their entire applications. They teach it's like immutable. They never actually update a value. They instead essentially create a new data point, and they're never deleting or modifying anything. So I think there is almost a merging in a way that you don't want to rewrite history. So you never want to like update a time series data point because you're changing what actually happened. And the same thing with like events. You want to have a track of what happened in your application or what happened with whatever event data you're collecting. So I'd say, what are the advantages? I'd say I'm not sure you can say one way or the other because they're almost merging to the same thing.
Okay, great. Well, Charles, it looks like we're running out of time, but just a last thought here. If somebody wants to get started with Influx Data or find out more, you've got some URLs up here. Do you have any recommendations for people?
Yeah, you can either we have a free pay, like it's not even pay as you go, it's free to start, and you don't have to give a credit card or anything. So you can go to InfluxDB Cloud. Or the other option is you can just like use the open source. So we have Docker images, or you can download the binaries, and you can just get started that way. I don't know if we have the link, but we have our InfluxDB University. So we have courses that kind of walk you through like the fundamentals, how to get started, kind of anything you'd want to know. Or otherwise, you can just check out the documentation and kind of find your own way.
All right, super. Yeah, and that link to get started with the free version of InfluxDB is there in your handout section as well, in addition to these links here. So excellent. Well, Charles, thank you. Great presentation. Really appreciate it. Appreciate all your insights in the Q&A too. Thanks for coming on.
Yeah, thanks for having me.
And before we wrap up, we have one more piece of business. It's the Amazon gift card prize drawing. And the winner of that gift card today is Sean Robertson from Tennessee. So congratulations to Sean. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Influx Data for making this event possible. And thanks as always for attending and for your great questions. That concludes today's event. Have a fantastic rest of your day.